Facts are not science, as the dictionary is not literature. Martin H. Fisher. Chapter 1. Chemical Reactions and Equations. Consider the following situations of daily life and think what happens when milk is left at room temperature during summers, an iron tawa pan nail is left exposed to humid atmosphere, grapes get fermented, food is cooked, food gets digested in our body, we respire. In all the above situations, the nature and the identity of the initial substance have somewhat changed. We have already learned about physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. Perhaps you may be wondering as to what is actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer to these questions. Activity 1.1. Caution: this activity needs the teacher's assistance. It would be better if students wear suitable eyeglasses. Clean a magnesium ribbon about 3-4 cm long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash so formed in a watch glass as shown in figure 1.1. Burn the magnesium ribbon, keeping it away as far as possible from your eyes. What do you observe? A burning magnesium ribbon in air and collection of magnesium oxide in a watch glass. You must have observed that magnesium ribbons burn with a dazzling white flame and changes into white powder. This powder is magnesium oxide. It is formed due to reaction between magnesium and oxygen present in air. Activity 1.2. Take lead nitrate solution in a test tube. Add potassium iodide solution to this. What do you observe? Activity 1.3. Take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this. Figure 1.2. Caution: handle the acid with care. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any change in its temperature? From the above three activities, we can say that any of the following observation help us to determine whether a chemical reaction has taken place. Change in state, change in color, evolution of gas, change in temperature. As we observe that changes around us, we can see that there is a large variety of chemical reaction taking place around us. We will study about the various types of chemical reaction and their symbolic representation in this chapter. Formation of hydrogen gas by the action of dilute sulfuric acid on zinc. Chemical equations. Activity 1.1 can be described as when a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. This description of chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation of the above reaction would be magnesium plus oxygen gives magnesium oxide. Reactants gives product. The substances that undergo chemical reaction in the following reaction 1.1, magnesium and oxygen are the reactants. The new substance is magnesium oxide formed during the reaction as a product. A word equation shows change of reactants to product through an arrow placed between them. The reactants are written on the left hand side LHS with a plus sign between them. Similarly, products are written on the right hand side with a plus sign between them. The arrow head points toward the products and shows the direction of the reaction. 1.1.1. Writing a chemical equation. Is there any other shorter way of representing chemical reactions? Chemical equations can be made more concise and useful if we use chemical formula instead of words. A chemical equation represents a chemical reaction. If you recall formula of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 gives MgO. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on both the sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for reaction. Equation 1.2 2 is a skeletal chemical equation for the burning of magnesium in air. Balanced chemical equations. Recall the law of conservation of mass that you have studied in class 9th. Mass can neither be created nor be destroyed in chemical reaction. That is, the total mass of element present in the products of the chemical reaction is equal to the total mass of element present in the reactant. In other words, the number of atoms of each element remain the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. In the equation 1.2 balance, let us learn about balancing a chemical equation step by step. The word equation for activity 1.3 may be represented as zinc plus sulfuric acid is equal to gives zinc sulfate plus hydrogen. The above word equation may be represented by the following equation: Zn plus H2SO4 gives ZnSO4 plus H2. Let us examine the number of atoms of different elements on both sides of the arrow. Element, number of atoms in reactants, number of atoms in products. As the number of atoms of each element is the same on both sides of the arrow, equation 1.3 is a balanced chemical equation. Let us try to balance the following chemical equation. Fe plus H2O gives Fe3O4 plus H2. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Fe plus H2O gives Fe3O4 plus H2. Step 2. List the number of atoms of different elements present in the unbalanced equation 1.5. Element, number of atoms in reactants LHS, number of atoms in products RHS. Fe1 3, H2 2, O1 4. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms using these criteria. We select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. To balance the oxygen atoms, to equalize the number of atoms, it must be remembered that we cannot alter the formula of the compounds or elements involved in the reactions. For example, to balance oxygen atoms, we cannot put coefficient 4 as 4H2O and not H2O4 or H2O whole 4. Now, partly balanced equation becomes Fe plus 4H2O gives Fe3O4 plus H2. This is partly balanced equation. Step 4. Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of H atoms, make the number of molecules of hydrogen as 4 on the RHS. Atom of hydrogen. The equation would be Fe plus 4H2O gives Fe3O4 plus 4H2. Step 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to the balanced, that is iron. To equalize Fe, we take 3 atoms of Fe on the LHS. 3 Fe plus 4H2O gives Fe3O4 plus 4H2. Step 4. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. 3 Fe plus 4H2O gives Fe3O4 plus 4H2. The number of atoms of elements on both sides of equation 1.9 are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trial method. As we make trials to balance the equation by using smallest whole number coefficient. Step 7. Writing symbols of physical states. Carefully examine the balanced equation. Does this equation tell us something about the physical state of each reactant product? No information has been given in this equation about their physical state. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formula. The gaseous, liquid, aqueous and solid states of reactants and products are represented by notations G, L, AQ and S respectively. The word aqueous is written if the reactant or product is present as solution in water. The balance equation 1.9 becomes 3FeS plus 4H2O gives Fe3O4 plus 4H2O. Note that symbol G is used with the H2O to indicate that in this reaction water is used in the form of steam. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or the below the arrow in the equation. For example, CO2 plus H2O gives CH3OH in presence of 340 atm. CO2 6SCO2 plus 12H2O gives C6H12O6 glucose plus 6O2 plus 6H2O in presence of sunlight and chlorophyll. Using these steps, you can balance equation 1.2 given in the text earlier. Types of chemical reactions. We have learned in class 9 that during a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reaction involve the breaking and making of bonds between atoms to produce new substance. You will study about these types of bonds formed between atoms in chapter 3 and 4. Combination reaction. Activity 1.4. Take a small amount of calcium oxide or quick lime in a beaker. Slowly add water to this. Touch the beaker as shown in figure 1.3. Do you feel any change in temperature? Formation of slaked lime by the reaction of the calcium oxide with water. Calcium oxide reacts vigorously with water to produce slaked lime, calcium hydroxide, releasing a large amount of heat. Calcium oxide, quick lime plus H2O gives calcium hydroxide, slaked lime plus H2O plus heat. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactant is known as a combination reaction. A solution of slaked lime produced by the reaction 1.13 is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also calcium carbonate, CaCO3. Calcium hydroxide CaOH2 plus calcium carbon dioxide CO2 gives calcium carbonate CaCO3 plus H2O. Let us discuss some more example of combination reaction. Burning of coal, C plus O2 gives CO2. Formation of water from H2 and O2. H2H2 plus O2 gives 2H2O. In simple language, we can say that when two or more substance elements or compounds combine to form a single product, the reaction is called as combination reaction. In activity 1.4, we also observed that a large amount of heat is evolved. This makes the reaction mixture warm. Reaction in which heat is released along with the formation of products are called as exothermic reaction. For other example of exothermic reaction are burning of natural gas, CH4 plus 2O2 gives CO2 plus 2H2O. Do you know that respiration is exothermic reaction? We all know that we need energy to stay alive. We get this energy from food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is respiration, the process of which you will study in chapter 6. C6H12O6 plus C6O2 gives 6CO2 plus 6H2O plus energy. The decomposition of vegetable matter into compost is also an example of exothermic reaction. Identify the type of the reaction taking place in activity 1.1 where heat is given out along with the formation of single product. Decomposition reaction. Activity 1.5. Take about 2 gram ferrous sulfate crystals in a dry boiling tube. Note the color of the ferrous sulfate crystals. Heat the boiling tube over the flame of a burner or spirit lamp as shown in figure 1.4. Observe the color of the crystal after heating. Have you noted the green color of the ferrous sulfate crystal has changed? You can smell the characteristic odor of the burning sulfur. 2FeSO4 ferrous sulfate in presence of heat gives Fe2O3 ferric oxide plus SO2 plus SO3. In this reaction, you can observe that a single reactant breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals FeSO4.7H2O lose water when heated and the color of the crystal changes. It then decomposes to ferric oxide Fe2O3, sulfur dioxide SO2 and sulfur trioxide SO3. Ferric oxide is solid while SO2 and SO3 are gases. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called quicklime. It has many use in manufacture of cement. When decomposition reaction is carried out by heating, it is called thermal decomposition. Calcium carbonate in presence of heat gives calcium oxide plus CO2. Another example of thermal decomposition reaction is given in reaction 1.6. Activity 1.6. Take about 2 grams of lead nitrate powder in boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame as shown in figure 1.5. What do you observe? Note down the change if any. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide. The reaction take place is 2 PbNO3 whole twice lead nitrates in presence of H2 gives 2 PbO lead oxide plus 4 NO2 nitrogen dioxide plus O2 oxygen. Let us perform some more decomposition reaction as given in activities 1.7 and 1.8. Activity 1.7. Take a plastic mug, drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers as shown in figure 1.6. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. Is the volume of the gas collected the same in both the test tubes? Once the test tubes are filled with respective gases, remove them carefully. Test these gases one by one by bringing a burning candle close to the mouth of these test tubes. Caution: this step must be performed carefully by the teacher. What happens in each case? Which gas is present in each test tube? Activity 1.8. Take about 2 grams silver chloride in china dish. What is its color? Place this china dish in sunlight for some time. Figure 1.7. Observe the color of the silver chloride for some time. You will see that white color chloride turns gray in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. 2 AgCl in presence of sunlight gives 2 Ag plus Cl2. Silver bromide also behaves in the same way. 2 AgBr in presence of sunlight gives 2 Ag plus Br2. The above reactions are used in black and white photography. What form of energy is causing these decomposition reactions? We have seen that the decomposition reaction require energy either in form of heat, light or electricity for breaking down the reactants. Reaction in which energy is absorbed are known as endothermic reaction. Carry out the following activity. Take about 2 grams of barium hydroxide in a test tube. Add 1 gram of ammonium chloride and mix with the help of glass rod. Touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction? Displacement reaction. Activity 1.9. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. About 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of blue color of the copper sulfate solution in test tubes A and B, figure 1.8b. Also compare the intensity of blue color of copper sulfate solutions in test tube. Also compare the color of the iron nails dipped in the copper sulfate solution with the kept aside, figure 1.8b. Iron nail. Why does the iron nail become brownish in color and the blue color of the copper sulfate solution fades? The following chemical change take place in this activity. Fe plus CuSO4 copper sulfate gives FeSO4 plus Cu. In this reaction, iron has displaced or removed another element copper from copper sulfate solution. This reaction is known as displacement reaction. Other examples of displacement reaction are zinc plus copper sulfate CuSO4 gives ZnSO4 plus Cu. Pb lead plus CuCl2 copper chloride gives PbCl2 lead chloride plus Cu. Zinc and lead are more reactive elements than copper. They displace copper from its compound. Double displacement reaction. Activity 1.10. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solution figure 1.9. What do you observe? You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as precipitate. Any reaction that produces precipitate is called as precipitation reaction. Na2SO4 sodium sulfate plus BaCl2 barium chloride gives BaSO4 barium sulfate plus 2 NaCl sodium chloride. What causes this? The white precipitate BaSO4 is formed by a reaction of SO4 to the power minus 2 and Ba2 plus. The other product formed in sodium chloride which remains in the solution. Such reaction in which there is an exchange of ions between the reactant and reactants are called as double displacement reaction. Recall activity 1.2 where you have mixed the solution of lead to nitrate and potassium iodide. What was the color of the precipitate formed? Can you name the compound precipitated? Write the balanced chemical reaction of this reaction. Is this also a double displacement reaction? Oxidation and reduction. Activity 1.11. Heat a china dish containing about 1 gram copper powder. What do you observe? The surface of copper powder becomes coated with black copper oxide. Why has thick black substance formed? This is because oxygen is added to copper and copper oxide is formed. 2 copper plus O2 gives 2 copper oxide in presence of heat. If hydrogen gas is passed over this heated material, copper oxide, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. Copper oxide plus H2 gives copper plus H2O. If substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. During this reaction 1.29, the copper 2 oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the other gets reduced during reaction. Such reactions are called oxidation reduction reactions or redox reactions. Copper oxide reduction to copper, H2 oxidation to H2O. Some other example of redox reaction are zinc oxide plus carbon gives zinc plus copper monoxide. MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. In reaction 1.31, carbon is oxidized to copper oxide, carbon oxide, monoxide, and zinc oxide is reduced to zinc. In reaction, HCl is oxidized to Cl2 whereas MnO2 is reduced to MnCl2. From the above example, we can say that if substance gains oxygen or loses hydrogen during reaction, it is oxidized. If a substance loses oxygen or gains hydrogen during reaction, it is reduced. Recall activity 1.1 where magnesium ribbon burns with a dazzling flame in air, oxygen, and changes into white substance, magnesium oxide. Is magnesium being oxidized or reduced in this reaction? 1.3 Have you observed the effects of oxidation reaction in everyday life? 1.3.1 Corrosion. You must have observed that iron articles are shiny when new but get coated with reddish brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Have you noticed the color of the coating formed on copper and silver? When a metal is attacked by substances around it such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are other example of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all objects made of metals, especially those of iron. Corrosion of iron is serious problem. Every year, an enormous amount of money is spent to replace damaged iron. You will learn more about the corrosion in chapter 3. 1.3.2 Rancidity. Have you ever tasted or smelt the fat oil containing food materials left for a long time? When fats and oils are oxidized, they become rancid and their smell and taste changes. Usually, substances which prevent oxidation, antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers help to slow down oxidation. Do you know that chips manufacturer usually flush bags of chips with gas such as nitrogen to prevent the chips from getting oxidized? What you have learned. A complete chemical equation represents the reactants, products, and their physical states symbolically. A chemical equation is balanced so that the number of atoms of each type involved in a chemical equation are the same on the reactant and product sides of the equation. Equation must be balanced. In a combination reaction, two or more substances combine to form a new single substance. Decomposition reactions are opposite to combination reaction. In a decomposition reaction, a single substance decomposes to give two or more substances. Reaction in which heat is given out along with products are called exothermic reactions. Reaction in which energy is absorbed are known as endothermic reactions. When an element displaces another element from its compound, a displacement reaction occurs. Two different atoms or groups of atoms are exchanged in double displacement reaction. Precipitation reactions are produced in soluble salts. Reaction also involve the gain or loss of oxygen or hydrogen by substances. Oxidation is the gain of oxygen or loss of hydrogen. Reduction is the loss of oxygen or gain of hydrogen. Thank you.